Hello, Math 20-3, and welcome to 6.2. We're going to be dealing with simple and compound interest. All right, so to begin with, what I mean by interest here is that let's say that you put $10,000 into a bank account. Well, depending on how much interest you get from that bank account, let's say if you only got a small amount, like 0.2% interest, then over time that's going to grow fairly slowly, right? The amount of money that's going to be in your bank account. But if I had a bigger percentage, like something like, I don't know, like 6% interest on your bank account, then that money in my bank is going to grow fairly fast. So that's kind of what we're talking about. The other side of that is, let's say that I borrowed $10,000. So that's how much I borrowed from the bank. Well, they are going to want interest for that money that they lent me. So it's going to be the same process that, let's say that they charge me, I don't know, something crazy like it's a bad credit card, 20% interest. Well, that means I need to pay that 20% of that $10,000 every year or every month or whatever the term is. Okay, but let's get to the definitions down here. So, simple interest. Simple interest calculates a percentage of the principal. So I'll start up here. So simple interest is interest paid only on the initial amount deposited or the amount borrowed, called the principal. So what I mean by that is, let's say that we deposited $10,000 into the bank account. That's always going to be the amount. So let's say if it was 6% or something of this 10,000. Well, that means, so simple interest means that it's always going to be 6% of that 10,000. So that's what we're talking about right now. Compound interest is going to be different. It would be 6% of whatever this number grows into as it grows over time. So that's the idea. The principal, I can't remember if I said this or not. Principal is the initial amount put down. So that's how much so you can remember principal. Another way is it starts with a P. You can think put down, like that's how much money you put in. And then the term is going to be how long. So the length of time in years over which the money is deposited or borrowed. All right, we're going to have a new formula. And that formula is going to be I is equal to PRT. And remember, when they're sitting beside each other, that means they're being multiplied. So that's really saying I is equal to P times R times T. All right, so I is going to be the amount of interest earned or due. And that's in dollars, right? So that's not a rate. So that's going to be an actual dollar value. That's how much extra money you either owe if you borrowed the money, or that you get if you deposited the money into a bank account. Okay, P is the principal. Remember that that's like put down. That's how much money you put down into it, or borrowed, or whatever. That's the original amount. R is the annual interest rate expressed as a decimal. So if we had something like 3%, remember how we write a percent as a decimal? That would be 0.03. If you want to, so remember that you can think about the decimal was like over here behind the 3. It moves over twice, and that's how we got this. Or you can say we divided it by 100. You get the same thing. If you divide a percentage by 100, you get the decimal. That's the number that goes in for R. And then T is the term of the investment or the loan, and that's going to be in years. So we're going to have to be able to solve for P, R, T, or I. So you'd normally have to rearrange this, but luckily I've done it for you on the formula sheet. So here it is, the simple interest formulas. These are all the same formula. They're just rearranged for different variables. So you guys have that. If you don't, make sure, come find me and make sure that you do have it. Okay, and then this last part here, it says A is equal to P plus I. All that's saying is like the total amount is A. So A is the final value for the investment. So what that means is, if I had, let's say I originally put down $10,000, and so that'd be my P, my principal, and then I made I don't know, $100 in interest. Well, then the total is just going to be A, right? So then you'd say A is equal to $10,000 plus 100. So that would be the total amount of money I had. That's all that's saying. All right. So example 1 says you would like to invest $5,000 in an account that offers simple interest. Calculate how much investment would be worth at each of the following rates and terms. So $5,000, that's how much you want to put down, or that's your principal, right? So right away I'm just going to put a P there because that's what that's going to be. And now it says 3%, so that's my R value. And okay, so that's going to be per annum. And then over a 2-year term, so that's going to be my time. Okay, really all you need to do here now is put it into the formula. So the formula is I is equal to PRT. So I is going to be equal to 5,000. And you can forget about the dollar sign if you want for now. I like to put it in brackets instead of the X. Doesn't really matter though. And then remember, R needs to be as a decimal. I know this is a decimal, like there's a decimal in it, but a decimal means you're getting rid of the percentage. So you're dividing that by 100 or moving the decimal place over. So 0.03 and then times 2. Okay, and if you multiply all those things together, you get $300. $300. And that's your answer for A there. So of this $5,000 initial amount that we put down, you'd end up with $300 after 2 years. That's how much interest you would make. All right, so that was example 1. Oh, and then the last step, I guess, was right here. You just add the two together, right? 5,000 that you started with plus that 300. That's how much you'd have in the end. Okay, now let's start with build your skills. Okay, so this one should be pretty straightforward. It's even laid out as principal, rate, and term. You just need to multiply them all together, but just make sure you change that into a decimal, right? So I'm going to let you guys go ahead and answer number 1. So go ahead and answer that now. All right. 15. Oh, no, sorry. It's page 15 on mine, sorry. All right, number 2. Okay, never mind. E. Let's go to E. So what happens to the amount of interest earned when the principal and the term stay the same, but the rate doubles? All right, so what I find helpful is write down the formula. So I is equal to PRT. And now it's saying that the principal and the term are exactly the same. So the number stays the same, but R doubles. So if R doubles, really that's going to make the whole thing double, right? If any of these doubled, if any number in here doubled, that would make my answer in the end double, because really you've got like 2R is what's happening there, right? So it would double as well. F, what happens to the amount of interest earned if the principal and the rate stay the same, but the term doubles? So again, if you just look at your formula, if these two are locked in as the same number and this one doubles, we've got the same thing. It's going to double your money. You've got, twice as big a number in there. All right. So calculate the value. So number 2 is what I'm on now here. Calculate the value of an investment of $600. So that's how much I'm investing. That's my principal, right? After 5 years, seems like a time to me, invested at a simple interest rate of 3.75%. So that's my R value. Again, I'm going to let you guys do this one. It's the same as above. It's just written as a word problem now. So, all right. Number 3, how much money would you have after 10 years if you deposited $1,000 at a rate of $450 simple interest per annum? So I'm not going to tell you which one's which this time, but go ahead and answer number 3 now. Okay, now compound interest. So before we were dealing with simple interest, right? And that was just looking at something like our $10,000 that we originally had invested. And then if we had like 6% of that, that would be 6% of that 10,000 for however many years. Now what's going to happen with this compound interest is that what we're going to do is, let's say we made, a certain amount of money on this $10,000 in the first year, right? We made some interest on that. And then now, let's say that this number all of a sudden got bumped up to, $10,100. Now the second year, we'd be taking 6% of that, right? So, and that's a bigger number. The percentage is going to be bigger. So it's going to get bigger faster. So compound interest is the one that we want. It actually makes, it's going to increase the amount of money you get a lot faster. All right, so these definitions on the side are going to be important. So compound interest is interest calculated on the principal plus interest earned in prior compounding periods. So that's kind of what I mean by like growing, right? It's going to get bigger and bigger and bigger. And then compounding period, that's how often we look to see how much money we have, right? That's the time between calculations of interest. So how often do we apply the 6% or whatever percentage it is to the bigger number? We'd like to have it applied as much as possible, right? That's gonna, we want this percentage of a bigger number is better, right? You get more money for that. So just some terms here. Interest calculated semi-annually. So semi, that means like more than one annually, has 2 compounding periods per year. Interest calculated quarterly has 4 compounding periods per year. Okay, and then interest calculated monthly, since there's 12 months in the year, there's going to be 12 compounding periods per year. And then interest calculated daily has 365 compounding periods per year. One thing I'd like you to change right now, though, there should be brackets on our new formula here. And your new formula is also on your formula sheet here, right? Actually, this one is going to be a bit more accurate than this one. This is kind of the simplified version of it on your formula sheet. Can I actually get you guys to change the one on your formula sheet to this one? So just write this down on your formula sheet because that's going to be more helpful for the questions in this booklet. Okay, so as we go through what we have here, A is the final value of investment. So principal plus interest, that's the total amount of money that I've made. So that's including my principal and my interest, right? P is the principal. So remember, that's how much you've put down. R is the annual interest rate expressed as a decimal, so same as before, right? So whatever the percentage is, just as a decimal. N is the number of compounding periods in a year. So whatever we figure out for how many times it compounds. And then T is the term of the investment or loan in years. All right. Okay, so I'm going to skip through the example ones and just get right into the practice problems. So number 4 says calculate the final value of a deposit of $5,000 invested at 3% per annum, compounded annually for 2 years. Okay, so what I'm going to do is write down my formula just to make sure that I have everything I need. So I'm going to write down A is equal to P times 1 plus R over N, and then to the power of N times T. And I'll show you how to put this all in your calculator. I know it might look a little confusing right now, but it's not too bad. Okay, so we're looking for A, right? That's calculate the final value. And then it says of a deposit of $5,000. So that's my principal. So I'm just going to put that in right now. So I'm going to say A is equal to 5,000. Okay, start my bracket. I got 1, because it's always a 1, plus, now I need an R. So R was that 3%, right? But I need to write that as a decimal. So that's going to be 0.03 divided by, now what is N? So it says compounded. This is where your N is going to come from. So compounded annually. So once a year, it's compounded once a year. If it was semi-annually, that would be 2. If it was quarterly, it would be 4. But since it's compounded annually, that's just once. It's one time a year. Okay, and then the same number is going to go in for N up here. So it's going to be 1. And then times, and then the time is 2 years. So times 2. All right, so I'm just going to simplify this a little bit. So I'm going to rewrite this again. Say A is equal to 5,000 times 1 plus, well, what is 0.03 divided by 1? That's just 0.03. And then what's 1 times 2? Well, that's just 2. Now, what we need to do is just make sure that you do what's inside the brackets first. That's one of the That's one of the biggest rules in math, is just making sure that whatever's in the brackets, that's what you do first. Okay, so I'm just going to rewrite this again now, maybe just for more room up here. So I'll write A is equal to 5,000 times 1 plus 0.03 is 1.03 to the power of 2. Now the next thing I'm going to do, just to make sure I don't mess anything up, is I'm going to go 1.03 to the power of 2 first. It's a little bit safer way of doing it, because I'll get a number from that, and then I'll just multiply by 5,000. I find that a bit safer way, but it would work too if you went 5,000 times this. It's the same thing. So we're going to go 1.03, and then to the power of, on mine, it's going to be x to the y. So it's like to the power of, it gives me that little hat symbol up there. So to the power of 2. And then equals. So now I know that's what my number is, right? So I've got that. That's 1.03 to the power of 2. And then I'm just going to multiply that by 5,000. Okay, so there's my answer. So 5,304. 0.5, which is really 0.50, right? Because we're talking about money. And then I put a dollar sign on it. Okay, so hopefully you got the steps down for that one. So number 5. Calculate the difference between the final values of the following two investments after 3 years. Alright, so I'm just going to split this down the middle, and on this side I'm going to do the compound interest one first, so that's, this one. So I'll write down my formula. A is equal to P times 1 plus R over N times R times T, or to the power of N times T. Okay, and then I'm just going to fill in things as I go. So A is equal to, my principal is 4,000 times 1 plus, my interest rate is going to be 0.035. And it's compounded annually, so my N value is 1, right? N value 1. So then N still up here. And then my time is going to be 3 years. That was up in the original part of the question. So times, shouldn't put left an N there. It should have been a 1. So 1 times 3. Okay, and then I'm going to rewrite this. It'll be A is equal to 4,000 times. This is going to be 1.035. I just went, got rid of that 1 because it didn't really matter, and then added it to 1 there. And then to the power of 3. Now I'm going to do the power part of it first just to be safe. So I'm going to go 1.035 x to the y, so that's my to the power of, on my calculator, yours might look different, to the power of 3 is equal to that, times 4,000. So 4,434. $87. Okay, so that's that one. Now simple interest. A simple interest formula was I is equal to PRT. So we got to figure out the interest and then add it to the principal in the end with this one, right? So interest is going to be equal to 4,000 times an interest rate of 0.035 times a time of 3 years. So that's going to be $420. But remember, I just need to add that back to my original principal, right? So that's going to be, so my total A is going to be equal to P plus I. So A is going to be equal to, the principal put down was $4,000 plus the interest I made, which I just figured out was $420. So this is just going to be $4,420. Okay, so there's my difference, right? So if I did this compound with a compound interest, this would have been my answer. If I did this with simple interest, that's how much I'd make. So the one was better than the other, right? Oh, so I guess our last step, it did ask us to calculate the difference. So we're just going to go this number minus this number. And that would be, what would that be? $14. All right, I'm running out of room. So it's going to be $14.87. Okay, number 6. All right, so number 6, I'm going to let you guys go ahead and do this one on your own. It's similar to the ones we've done so far. I'll write down the formula. A is equal to P times 1 plus R over N to the power of N times T. So I'm going to let you guys go ahead and do number 6 now. So now what we're going to do is change up like how it's compounded, so it won't necessarily always be annually. It'll be semi-quarterly or monthly now. It's not really going to change much. All that's really going to change is what that N value is. Not much different though. Let's skip those and let's do some on our own here. So 7 says calculate the final value of an investment of $4,000 that earns interest at a rate of 4% per annum for 8 years with the following compound period. So I am going to write down my formula. So A is equal to P times 1 plus R over N. Those both look like N's or R's, don't they? And T. All right, so we know it's going to be 4,000. That's going to be the same for all of them. That's how much we put down, or our principal. So $4,000 times 1 plus our interest rate is going to be 4%. So 0.04 over. Now here's the part that changes. Well, I guess it's not even going to change on the annual one, right? Because that's going to be once. So we're going to say, so N will be 1. And then N will be 1 again up here. And then it's over 8 years. So times 8. And if you put that into your calculator, like what the ways we did before, oh, that should be an A. You should get 5,474.28. All right, so I'll start you guys off for B here, and then let you finish the other ones. So for B, we're gonna say A is equal to P times 1 plus R over N, and then N times T. That's gonna be 4,000 for all of them. 1 plus, the interest rate's the same, 0.04. And now the thing that changes here, semi-annually, remember what that means? That means N's going to be equal to 2. So twice a year is what that's saying. So N's 2, and then 2 for N up top again, and now my time is still 8. So 2 times 8. All right, so I'm going to let you guys go ahead and figure out what 7B is. Well, actually, we'll do all at the same time. So 7B, C, and D. I'll get you guys to go ahead and answer those now. Okay, number 8. All right, I'm going to let you guys do number 8 on your own too. I'll read it here for you though. What is the difference in the amount of interest you will get on a $10,000 deposit at 3.75% per annum for 1 year if it is compounded annually? So N is equal to 1, right? Compared to daily. And now it really tells you what N's equal to here too, right? N is equal to 365. So really, we just have 2 formulas to do. You're going to do it twice and then subtract them because you want to figure out what the difference in the amount is going to be. So go ahead and answer number 8 now. Okay, number 9. Oh, and yeah, skip the example before this one. I kind of skipped ahead. I'm on page 300. So number 9, we're going to skip. It seems like it's going to take quite a long time to do the whole thing, and I don't know if it's worth it. So let's skip number 9. And now we're going to go on to the rule of 72. So the rule of 72 is a way to estimate the time it takes for an investment to double in value. So that's it. This one's going to be pretty easy, actually. So one thing to note that the rule of 72 is just an estimate. It's not going to give you an exact rate, but it's the approximate. Yeah, I already said that. Okay, so here's what it is though. So years to double your investment is going to be just the number 72. It's always going to be 72 divided by the interest rate, not as a decimal, but actually as a percentage. So you have this rule of 72 also on your formula sheet. So right here, right? So we've kind of got double is going to be equal to 72 divided by interest rate. So, and that's as a percentage. If you want to write on here, I can't write on this one, but write it as a percentage, not a decimal. Whatever you have to do to remember that. That's the only way you can mess this up, is if you put this as a decimal like we usually do. It needs to be a percentage. So write that on there. Okay, so to build your skills here, the only tricky part here is that they kind of give you more information than you necessarily need. Because it says use the rule of 72 to estimate how long it would take to the following investments to double in value. So they give us these values, and we want to know how long it would take to double, right? That'd be kind of tougher to do with the equation. But with this rule of 72, all we have to do is go on the formula sheet. It says double is equal to 72 divided by your interest rate as a percentage. So that's it. We're just going to go 72 divided by 4. That's literally it. Which is going to be equal to 18. And this amount of time it takes to double is going to be in years. So 18 years to double. So this one, I can even help you out here. It's going to be 72 divided by something. And this one's going to be 72 divided by something. So go ahead and answer 10B and C now. Okay, so number 11 says, if you want to double your money in 15 years, at what rate of interest would you need to invest your money? All right, so with this one, let's write down our formula again. So double time, that's what they've given us, right, is equal to 72 over our interest rate. So if we plug our numbers in here, I'm just going to write it over here for lack of space. It's telling us that we're going to double it in 15 years. So I'm going to put 15 in place of my double time, because I know what it is equal to, it's always 72, divided by, and now this is what it's looking for, our interest rate. So probably the easiest way that we've been kind of dealing with a few times is if you put this 15 over 1, we can just cross multiply, right? So that's going to be 72 times 1, which is just 72, right? Doesn't really matter. Divided by 15 gives you your interest rate. So really it's 72 divided by 15. So that's going to be, so our interest rate is going to be, what do they say, 4.8. 4.8 and percent, right? This isn't our decimal. This is literally the percentage. Okay, practice your new skills. So number 1 says calculate the amount of simple interest earned and the final value for each of the following investments. So remember, this is our formula. I is equal to PRT. That's all I'm going to say. So go ahead and answer 1A now. Okay, so we got the same thing going on here. Go ahead and answer number 1B, C, and D now. Number 2. Okay, number two, you're going to have to do actually 4 questions. There'll be A, B, C, and D. And they are going to be using the numbers from the last question. So instead of using your simple interest, we're going to use our compound interest. So we're going to say A is equal to P times 1 plus R over N times T. So this is where we're going to start, right, for A. And we're going to use this information. So principal of 400, interest rate of 1.25%, 8 years. And then the key bit that's going to change here is that it's going to be compounded monthly. So what's that mean? Remember, n is equal to 12. So that's it. That's all I'm going to tell you. So go ahead and answer to A, B, C, and D now. Number 3, since we skipped it in the book, we're going to skip it on here too. So you can cross out number 3. All right, number 4. Tamika deposits $4,000 into an investment account that offers 3% interest per annum, compounded daily. Make sure you know what that means. What does that mean? How much will her investment be worth after 3 years? How much will it be worth after 10 years? So go ahead and answer for A and B now. Number 5. An investment offers a rate of 2.8% annum, compounded annually. What does that mean? Use the rule, well, actually, we might not need it, sorry. Use the rule of 72 to determine about how long it will take for the value to double. Round your answer to the nearest whole number. So if you need to go back to the rule of 72 to figure that one out, go back. Should be pretty straightforward. So go ahead and answer number 5A now. Okay, 5B says use the compound interest formula and investment of 1,000 to check your answer. What is the value after that number of years? So really what you're doing here is you are going to use your formula. A is equal to P. You're going to use your compound interest formula. You're going to put in $1,000 for one. And then what you're going to do is use your number from above, the one that you figure out for your time, to go in here. That should be interesting, right? So it's going to say, so what's the value after that number of years? So that's the idea there. That's what you're doing. Okay, so go ahead and answer 5B now. Okay, number 6. Regine has a $1,000 investment that offers an interest rate of 2.5% per annum, compounded monthly. What does that mean? If he invests it for 5 years, how much will the investment be worth at the end of the term? So go ahead and answer 6A now. Okay, and then 6B says approximately how long will it take for his investment to double in value? So go ahead and answer 6B now. Okay, number 7. Which is the better investment over 5 years? An investment that offers a rate of 1.9% per annum, compounded annually, or an investment that offers a rate of 1.75% per annum, compounded monthly? So really, you just need to do the formula twice and see which number ends up being bigger. So go ahead and answer number 7 now. All right, and then number 8, calculate the final value of an investment of $5,000 over a term of 10 years and a rate of 2.6% at the following compounding periods. Okay, so we've done one like this right from the booklet before, right? So go ahead and answer 8A, B, C, and D now. Okay, and that's going to be it for 6.2. I'll see you guys in the next video.